Hello, and welcome to Developing Serverless Application using AWS AppSync. This webinar is going to be a combination of slides and demos. So we are going to go over how to build a serverless application using AWS tools and services like AWS Amplify and AWS AppSync. Finally, we will go over how to gather analytics data to get better insights into how your customers or users are interacting with your sample e-commerce application. So my name is Tony Ouma, and I'm a solutions architect here at AWS. And I have been building serverless application in AWS for over 2 years, both as a customer and currently at AWS. You can also reach me on Twitter at DevOpsStream. So let's get started. So the agenda for today, we are going to first look at what is serverless and what it means to you as an engineer. Then we are going to go over the high-level architecture of the sample e-commerce application that I've built. And in the next item, I will show the finished product. I just want to mention in between the slides, we'll actually write some code and do some deployments. We will then switch gears and have to go through over the overview of the services used to build the front end and the back end application. This will be mainly a level 200 introductory overview. So we are not going to go into deep dive of the individual services that we are using today. Towards the end, I will introduce some ideas on how to do analytics and in this type of application. And this will be a good way for you to get a glimpse of how the different AWS services work together. Finally, I'm going to take questions from you, and hopefully we're going to enjoy ourselves. You have heard us talk about shared responsibility model in the past. Simply stated, a shared responsibility model implies that there are parts of the system that AWS is responsible for, and there are parts of the system that you as a customer must take responsibility for. In many cases, we do provide tools, and there is a rich ecosystem of open source and commercial products that make it easier for you to own your side of the responsibility in the box. There is no hard line on where this line is drawn between two parts of a shared responsibility model. For example, if you look on the slide, you can realize on the compute side, it means that you own more on the responsibility of making sure that the compute is patched, it's secured, and is configured in a way that doesn't compromise your application. And while you're moving towards the right-hand side, you realize that AWS is taking more of that responsibility. You can imagine something like a service like RDS. With RDS, AWS is doing all the heavy lifting as far as patching your operating system and making sure that the database is configured properly. So I'm going to move the next slide. And in this next slide, we are going to go over and talk about what is serverless. So when you think about it, what is serverless? Serverless is an operational model that spans many different categories of services. And in AWS, when we say serverless, we mean it is the removal of the undifferentiated heavy lifting that is server operation. This is an important distinction for customers because it allows customers to focus on building of the application rather than the management and scaling of the infrastructure to support the application. This means not thinking about the infrastructure or scaling. It means only, you only pay for the value, or it means availability and security is already built in. So the way we view this is that there are specific tenets of what it means for an application, for a service to be serverless. For one, there is no infrastructure to provision or to manage. In other words, you don't have any servers to operate, to patch, and things like that. It also automatically scales by unit of consumption. So you want to think about, instead of paying for server units, you're actually paying for the consumption of a value that values to you. This can be the number of execution in this, for example, in Lambda, AWS Lambda service, which is our compute serverless service. And also you pay for value billing model. Another very important aspect of it is built-in availability and fault tolerance. There is no need to architect for availability because it's built into the service. So today, let's take a step back and look at what we are going to build today. So here is the actual overall architecture of the application that we're going to build today. When you look on the left-hand side, you have a client, and that client can be a web browser or it can be a mobile application. And on the static content, where we have the service itself, we are going to have the service going through our content distribution network service, which is called Amazon CloudFront. And then our application is going to be mainly built using Angular, and we are also going to use the Amplify framework to help us interact with the AWS resources in the back end. When you look at the bottom on the API side, we are going to use a managed service called AWS AppSync, which is our managed GraphQL service. And as far as user authentication, we are going to use Amazon Cognito. Now, on the back end where we're going to do in analytics, I'm going to use a service called AWS Pinpoint, and the data is going to be sent from AWS Pinpoint to Kinesis Firehose, and then finally to Redshift, and then we are going to visualize that data using AWS QuickSight. Okay, so let's look at the sample e-commerce application that we are going to use today, and I'm going to switch to my browser and go to the URL. So our sample e-commerce application is a typical application that you'll usually find with the same functionality. You have authentication, you have a shopping cart, and you have the ability to browse the items that you want to shop, and you can add them to the cart, or you can actually remove items from the shopping cart. And when you look into how the application has been developed, we're actually using just a Angular JS framework. And you have the basics, being able to log in, being able to browse the inventory, adding items to the cart, and checking the items out. So before we dive into starting to develop that e-commerce application, let's talk about Amplify Framework. So Amplify Framework is composed of two main components, and that is the framework itself and the CLI. So the CLI is more like an easy entry point for developers or new developers who are new to AWS, and it allows you to provision the cloud resources that you need for your application. In this case, you might be having a resource like a database, or you have a resource like an endpoint, or something like AWS Cognito for authentication. And the AWS CLI command allows you to create those specific resources. What the AWS CLI command is using under the hood is actually using CloudFormation, and it just creates the CloudFormation for you and then deploys the CloudFormation in AWS platform. And then the next component is the framework, and the framework is a JavaScript framework that is actually supported by frameworks like Angularjs, React Native, even Android. And it allows you to interact with the resources that you just created using the AWS CLI command. So you want to think about, hey, you have already created a Cognito user pool, and you're trying to access that Cognito user pool in Angular component. Then you can use the classes that are provided for you in the framework to access those specific AWS resources. So let's switch and get started using Amplify. So what we're going to do today, as far as setting up Amplify and AngularJS, we are going to install the Angular CLI command using the npm command, which is npm install -g for global, and install the Angular CLI command. Then the second thing we are going to do is to install the Amplify CLI command. And then after we install the Amplify CLI command, we are going to create a new project. In this case, we're going to call it my app. It can be any name. And then we are going to change our working directory into that new project that we just created. And then finally, we are going to install the Amplify framework inside that particular project. During this demo, it's not a requirement that you are very familiar with Angular JS. The whole idea is to see how the development workflow works as far as setting up the Angular CLI and creating a sample JavaScript application. That's what we're going to do today. So I'm going to switch to my terminal and see how we do that. So back to my terminal, I do have a sample workspace. This is just an empty directory. And what we want to do is create, actually install the Angular CLI. So what I'm going to do is say npm install -g Angular CLI. So I already have Angular CLI installed in my local workstation. In this case, if you're doing a brand new installation, it's going to take a little bit longer. Next, we are going to install the AWS Amplify CLI command. Again, we're doing this globally. Great. So now once we install the Amplify CLI command, we are going to go ahead and create a new project. I'm going to call it my app. While it's doing this installation, I just want to mention that after this installation is done, we are going to install the AWS Amplify Framework inside this particular project. And we're going to do a minor configuration in this case because we are using the newest version of Angular. We want to make sure that we configure the schemes, which is going to be, you'll see on my next, once the installation is done. Okay. Now that installation is done, we have a directory with a new project called my-app. So I'm going to change my working directory to that new project. And if you look inside the directory, it's just the standard AngularJS application you have where you have the modules and you have your source code in the source directory. So what I'm going to do here is actually install the Angular framework. And I'm going to save it. And I'm going to say AWS Amplify. Got a typo. There we go. Okay, so now that the installation is complete, we have our project. Let's go ahead and configure the initial configuration that we need for the polyfills. The way we do that, we come here and make sure that we do have the window as many, global.window polyfill. This is because the new Angular 6 greater than 6.0 doesn't support, it cannot run without having those polyfills enabled for AWS Amplify. So now that we have that configured, let's go back and continue. So now we have initialized the project. We need to initialize the project by doing the Amplify init. And the name of the project is going to be my-app. The environment is going to be dev. I'll have to select my editor, Visual Studio Code, and it's JavaScript. It's Angular, source, and then the destination is going to be this-my-app. Everything else stays a default configuration. So what it's actually doing, it's deploying the CloudFormation to our AWS account. And that is more like a staging environment. You create an S3 bucket, and moving forward, the Amplify CLI is going to use those, the resources created to configure your environment. You can see here that it's creating an S3 bucket. So this will take about a minute or so. Actually, it's done. So going back, now that we do have a project that has been initialized, the next thing we want to do is actually to start adding the components that we need for our application. In this case, we're going to add the auth. What auth is going to do, it's going to create an Amazon Cognito user pool. And then if you add analytics, it's going to create a Pinpoint endpoint. And then finally, before, then you can add the API, and also you can add the hosting. What the API will do, it's going to create for us the API endpoint that we're going to use here. In this case, it's going to be an AppSync endpoint. And speaking about the hosting is going to be the location where we are going to have our static content, in this case, our JavaScript files and HTML files and CSS files. Usually we store that on our Amazon S3 bucket, which is our object storage. And then finally, after we have added those components, we have to do an Amplify push, which will actually deploy the CloudFormation. So let me go ahead and add the authentication piece. So we do that by saying Amplify add auth. And I'm going to select the default configuration for everything. So here I'm going to say email for logging in, email. So now if we look at Amplify status, we see that we have our Cognito user pool ready to be created, and the state here is ready to be created. And of course, it's going to use CloudFormation. So before we go ahead and do this deployment, let's talk about authentication for a bit. So authentication. So the main component that we use for authentication is Amazon Cognito. So Amazon Cognito is a simple, secure, and fully managed service that lets you add user sign-in capabilities to your web and mobile applications. It scales to millions of users, and it does support federation from social providers like Google and Facebook, in addition to enterprise federation like Active Directory via SAML. So as a developer, you want to focus your time on what is important for your application, while Amazon takes care of the undifferentiated heavy lifting of securing authentication for your apps. So Amazon Cognito does support multi-factor authentication and encryption of data at rest and data in transit. It's also HIPAA eligible, and it's PCI DSS compliant. So I'm going to switch back to my console and show how we configure our authentication in our newly created Angular application. The first thing we are going to do, of course, is Amplify add auth. But if you remember in our previous step, we already did that. And then once you add the auth, we can do a push. And what the push is going to do, it's actually going to create a new Cognito user pool. And then the next thing we want to do, we want to install the Amplify framework again in the application itself. And this is going to allow you to have the Angular components that you need for AWS Amplify. And then finally, optionally, if you are going to use the default CSS files that we have for Amplify Framework, you can run the step 4, which is npm install, and you're going to install the Amplify UI CSS components. So let's see how that looks like in the terminal. Components. And I'm just going to copy the command here. Then it's done. Then we are also going to use the default CSS files provided by Amplify. Oh. Okay. Then the next thing we want to do is switch back to our Visual Studio Code and import the new CSS themes that is provided by the Amplify framework. So switch back to the UI. And then we find this style, the CSS. And here, CSS themes that we have for AWS Amplify. So at this point, let's recap what we have just done so far. So we initialized the project, we installed the default AWS Amplify CSS themes, and we also added the Cognito user pool. So the next thing we want to do is to create an Angular service. And for those who are not very familiar with Angular service, it's basically a mechanism to use a dependency injection, and it allows you to use various components within the application on classes that are not even dependent on each other. So in that case, we create a service, and then we are able to inject that service on the rest of the application. So let's see how we are going to do that. So if you look in the app.module.ts, the first thing we are going to do is to import the Angular module. And then we're also going to import the Amplify service from the new framework that we just imported. And then we are going to configure the services by specifying in the provider section that we have a new Amplify service, and that service is going to be available within the entire application. At the same time, we're also going to add the Amplify module in the import section. So let's switch back to our editor, the new module, and in the providers, we are going to declare the new Amplify service. So what this is doing is it's making the Amplify service be available to other classes within the application that is going to use Amplify in this case. So now, when we go back to our slides, in the app.module, we import the modules, we set up the service, and now the service is available to the rest of the application. So the next thing we want to do is configure the actual Amplify service itself. And what I mean by that is that we want to make sure that we have the config file defined. In this case, the config file is going to be AWS exports. And this is the point where you can also turn on the log level. In this case, I'm going to turn on the debug. And I'm also going to make sure that Amplify is going to expose all the functionality that we need. In this case, we are going to need analytics. We are going to need authentication. all that is going to be called within one service. So what you have to do to get that done is to add the following line, that is the code snippet you see here in the main.ts file. So let's switch back to the editor and see how that's done. So we go to main.ts, and right below here, I'm just going to copy and paste. And here we are importing the Amplify service. We are setting the log level, which in this case is going to be debug, and we configure our Amplify service. So at this point, our project is ready to be started. So let's see how that's going to look like in the terminal. So to start the application is ng serve, and we are going to run it at port 8000. Okay, and let's switch to the browser and see how our new application looks like. So here I'm going to open a new tab. Then we're going to say localhost, and we are listening at port 8000. It's a standard Angular application. You see everything is still at default. And let's open our developer console. And we don't get any errors. So the last thing I want to do is actually to add the authentication component. So let's see how that can be achieved. In this case, because it's just a default installation, we're going to use our HTML file here, which is the app.component of HTML. And what I'm going to do is just delete all that. And then I'm going to add the Amplify component. So this component for Authenticator comes with the Amplify framework. This is the advantage of using the Amplify framework, is that we do have components that is available for you as a developer to start using immediately. So you don't have to write this component from scratch. So let's switch back to the terminal and see if it compiled. And yes, it did compile. And if we go back to the browser, there we go. So we already have a login page by just writing a few lines of code, which is we added the component that comes with the Amplify framework, and we configured the Amplify framework, making sure that the service is available to all components within the application. And just by adding just one line of code in our view, we are able to get a clean login screen. So the next thing we want to do is move on and talk about APIs. So when you're thinking about an API, the first thing that usually comes to mind is, how do I build an API for my front end to be able to utilize that? And which technology should I be able to use? And also you want to worry about, hey, how do I authorize the users to use my API? And that's where we have to start by thinking about what AppSync does. So AppSync is a fully managed service that simplifies application development by letting you create a flexible API to securely access, manipulate, and combine data from one or more data sources. AppSync is a managed service that uses GraphQL to make it easy for applications to get exactly the data that they need. So let's look at AppSync architecture. So with AppSync, you can build scalable applications, including those requiring real-time updates on a range of data sources, such as NoSQL data stores, relational database, HTTP APIs, and your custom data sources with AWS Lambda. So for mobile and web apps, AppSync additionally does provide some local data access when devices go online. It's still capable of doing data synchronization and with conflict resolution. And that is very interesting when you think about it, the way it works with AppSync. The application first reads or writes to a local storage in a mobile device or a web browser. And then behind the scene, AppSync automatically synchronizes the data with the backend. And this enables the developers to build applications that offer good user experience, because now you don't have that dependency of making sure that you have a good network connectivity. So before we start looking at AppSync and GraphQL, let's take a step back and think about or talk about what is GraphQL. So what is GraphQL? So let's imagine that we do have booking service that is backed by a REST API. If my client needs to access a list of flights, I have to make an API call to a specific endpoint. In this case, that endpoint is going to be flights. And then the API will return IDs for the available flights. And if I need data about a specific flight, I have to use the ID that I just retrieved from a previous call and use that to call another endpoint. In this case, it can be flight info. And maybe I need to make another third call. In this case, that call can be to flights by airline. And what you see there is that I need to create different endpoints and customize them accordingly. So you can imagine that won't scale as an API. It gets more complex with more endpoints. It becomes very difficult to build those relationships between the data coming from different endpoints. Now, with that said, API is a proven technology, right? It has some advantages to it. REST is a true and tested API technology with established architectural patterns, and it's based on standard HTTP calls. However, if you need to build relationships again between those endpoints, that's where you are going to bump on some difficulty, and you have to implement that within your code. And GraphQL is meant to solve those particular problems. So AppSync uses GraphQL technology, and it's a technology that was developed by Facebook, and it was created for web and mobile development with data descriptive programming language. So it allows front-end and back-end teams to work independently. And GraphQL is emerging as an alternative API approach to REST and has been adopted by companies like Intuit, Twitter, Pinterest, Facebook, GitHub, and the list goes on and on. So how does AppSync work? So at the top, you're defining a schema, and you want to think about the schema. This is going to be your types, your queries, your mutations, and in the upcoming slides, I'm going to show you how that looks like. And then you have your clients. In this case, those clients can be mobile applications or web applications that need to call the actual AppSync endpoints. And then finally, you have your data sources, and your data sources can be DynamoDB, a Lambda function, or Elasticsearch. And then you have the resolver. The resolver essentially is a function that is responsible for fetching data from a location to fulfill a request. For instance, a resolver might query a database to get a stored record, or it will just compute a value directly. Resolvers are attached to fields on a type in a GraphQL schema, and these are actually executed at runtime. So how does the query language itself look like? The query language for GraphQL, typically you have, you have the mutations, and you want to think about mutation as being able to write and update data. And then you have subscriptions that are specifically linked to mutation and allow you to receive data in real time whenever data is changed or updated. And then, of course, you have the queries. The queries are a way for you to read the data. The good thing is that with Amplify CLI, it simplifies for you the creation of the mutation. You don't have to create this if you're just getting started as a new developer. So how do you configure the API? If you realize here we have the same pattern whereby if you want to create a new API using Amplify CLI, you just add the command amplify add API. And on the next screen, it's going to ask you if you want to create a REST or you want to create a GraphQL API. In this case, we're going to create a GraphQL API. And then finally, it's going to ask you about how you want to authenticate against the API. In this case, we are going to use Amazon Cognito user pool, but you do have the option of using an API key. And then finally, you do an Amplify push. So once you've created an API using the AWS CLI, what the AWS CLI is going to do, it's going to generate for you the schema. And that schema, I'll show you in a minute where that schema is saved. But essentially, a schema looks something like this. What you see here, we're defining a model, and that model is the entity that we are going to use for our API. In our case, we're going to have two models. The first model is for the product, and that product has an ID, has a name, and things like the image and the department. And then another model that we're using here is the cart. And in the shopping cart, the same thing, we have the product, and we have the SKU, the price, and the owner. And of course, the different queries that we're going to use here, we have the get product that will return us an array of products. And then we also have a query that will return to us a single entity, which is product. And we have a query that will return to us the items that we do have in our cart. So if I switch back to my editor, I have a sample e-commerce application here. And the first thing we want to do is look at our schema. And our schema, you can see here, we have the models defined. And that is actually generated for us by Amplify. And where that file is stored is if you come to Amplify directory and you scroll down, you'll be able to find your API. And in the API, you can see that we have the schema defined there. Also, we have the Angular services that has been generated by Amplify CLI. And here you can see that we have those services, and it's giving us all the methods that we need to access our data. And then finally, if you go to the modules, we can see that we just created here an Amplify service that we had created earlier. So we have our schema. And when we switch to our AWS console, you can see that behind the scene, Amplify was able to create for us a DynamoDB table. And in that DynamoDB table, in this case, the DynamoDB table that I'm looking at, you can see these are the items that we do have in our shopping cart. And here we do have another DynamoDB table that I am using for the products. But the whole idea is I didn't have to create the DynamoDB tables by hand. That's the advantage of using the AWS Amplify CLI. It does all that for you in the background. So if you're a new developer who's just getting started with using this particular tool, it's a good way to get started in terms of wiring all the services together. So let's switch gears here a little bit and talk about analytics. Same thing, if you need to add analytics in our application, we just do Amplify add analytics. And then finally, you do Amplify push. What that is going to do for us in the background is create an Amazon Pinpoint instance in our account. And using that, we are going to send events to application. So let's switch here and talk about Amazon Pinpoint. So Amazon Pinpoint is a fully managed service that provides you with real-time data so that you can quickly provide your customers with a better engagement experience. The real-time data enables the Pinpoint API to deliver on-demand messages, while at the same time, it's a good way for us to collect custom events from our application. You want to get better visibility into what your application or what your users are doing within your application. It allows the developers to quickly be able to gather those events and send those events for things like analytics to get an understanding of what the users are doing within your application. So how do you configure Amazon Pinpoint? So once you add the analytics using the Amplify CLI, the next thing you have to do is come back to your code. And of course, using the Amplify service that we had defined earlier, we inject that into the constructor. And at this point, we are ready to start creating custom events. And the custom events are going to look something like this, right? So the first thing you do is you specify the name of your event and the attributes of your events. And with that, already the event is starting to be sent to Pinpoint. Let's see how you send the data to Pinpoint, how that looks like in our application. So here we go to Pinpoint, which was created using AWS Amplify CLI command. And here I have our sample application. Then if you go to analytics, then you look at the events and look at all the events that we're receiving. We see we have the different events, like the product was selected, we have checkout and add to cart. And if you switch back to our browser, you can see any minute I add an item, that's data being sent to Amazon Pinpoint. In this case, you can see that I have an event, and that event just is called product. When I add a product to the cart, it's sending that event. And that event is actually recorded by Amazon Pinpoint. And if we come here, we can actually do the filter by the type of events that are being sent to Amazon Pinpoint, and we can see the event attributes, which we are actually defining in our code, here in our sample code. So here I have the attribute with the product name and the price. So the advantage is you have the flexibility to create your own custom events depending on what you're trying to capture of the users, all the clicks, all the products that they are selecting, when they're logging in and logging out. You get the flexibility of creating those events, and those events are being sent to Amazon Pinpoint. So the next thing we want to see is, once the events have been sent to Amazon Pinpoint, how do you visualize this data? How do you store this data in long term? And that's going to come up in the next slide. What we want to do is to configure Amazon Pinpoint to send our data to Kinesis Stream. And let's switch back and talk about what is Amazon Kinesis Firehose. So Kinesis Firehose is the easiest way to reliably load streaming data into data lakes or data stores, or even just analytic tools. It can capture, transform, and load streaming data into Amazon S3, Amazon Redshift, or Amazon Elasticsearch service. So after you create your Redshift cluster, you can create an Amazon Kinesis Firehose delivery stream that will deliver your Pinpoint data to the Redshift cluster. So when we switch back to our AWS console and we go to Kinesis, and we go to Firehose. So here I do have one delivery stream. And if you see the destination of where the data is getting delivered, it's actually getting delivered to Amazon Redshift. And I have a Redshift cluster here. So going back to Pinpoint, to our Pinpoint application, if you go to settings, then you go to event stream. This is where you configure the stream where you want to deliver the Pinpoint data. And that's mainly because Pinpoint is not meant for long-term storage. So next, let's talk about Amazon Redshift. So Amazon Redshift is a fast, scalable data warehouse that makes it simple and cost-effective to analyze all the data across your data warehouse and data lakes. And to get a better understanding of how that works between between Pinpoint and Kinesis streams, and how Kinesis stream is able to deliver the data to Redshift, there is a main config file which is called the JSON paths file. And that JSON path file is what will do the mapping. It's a file that looks like this. So in the JSON path file, the JSON path is used to interpret the unstructured Pinpoint data into specific Amazon Kinesis columns. So what you have to do is you have to create a new Redshift cluster, and then you create the columns that you're going to need, and then you have to configure the JSON paths when you are setting up the delivery stream. And let's see how that's done. So you come here, and then you go to Kinesis streams, Firehose. And here we are saving the JSON paths into an S3 bucket, and that JSON path is able to interpret the columns that we need from based on this unstructured data that's coming from Pinpoint and being sent over to Redshift cluster. So who are the customers who are actually building these type of applications right now? I'll talk about that in the next slide. These applications in the AWS platform. So we have Arizona State University. So Arizona State University is a top-ranked research university located in the greater Phoenix metropolitan area. ASU uses AppSync in their real-time mobile chat app, which caters to a student population of over 100,000. We also have American Commercial Barge Lines, which operates equipment for transporting cargo along 7,200 miles of US inland waterways. So ACBL uses AWS AppSync in their infrastructure for service-to-service communication and in their proprietary internal front-end application. And then, of course, we have Ticketmaster, which is North America top online venue for ticket sales and distribution, and one of the continent's highest-ranked e-commerce websites. So Ticketmaster hosts 26 million unique visitors every month, and they are also building applications using AppSync. So what are the key takeaways? The key takeaways here is that as a developer, you want to focus on what's important for your business, and you want to consider using GraphQL and AWS AppSync for your next API. You want to use Amplify for rapid front-end and mobile development, and it's easy to get started with it if you're a new developer in AWS, or even if you're an experienced AWS developer and you're just trying to figure out how do you wire all these different services together to build a prototype quickly. So there's the link to the documentation to get started with Amplify. And on the next few minutes, I will be taking questions.